Good afternoon, everybody, and thank you for taking time out of your day to join us for our webinar, our May webinar called Multicast ABR. My name is Jason Tebow. I am the Executive Director of the Streaming Video Alliance, which is hosting this webinar. And as you can see by our slides, we've got a fantastic panel here from a broad cross-section of technology companies that have lots of experience with Multicast ABR. Now, just a little bit about the Streaming Video Alliance. We are a global organization dedicated to building solutions, specifications, best practices for critical challenges in the streaming video industry that will eventually, hopefully, create a better video experience for viewers and improve adoption around the world. And obviously, you can find out more about us at streamingvideoalliance.org, and the URL is at the bottom of the slide. This will also be recorded, so we will be posting an on-demand version of this on our website probably a little bit later today. And then I believe an email will go out to anybody who was registered but couldn't attend. And so obviously you'll also get a link to the on-demand version. You can pass that around to colleagues and other employees, who may have missed this event. All right, so to start off for the day, I would like to have our panelists introduce themselves. So they'll spend about 30 to 60 seconds kind of just explaining who they are and what their company does, and maybe a little bit about their experience with Multicast ABR. And then once we finish with our introductions, I will jump into our questions, and then we can start our discussion on what is really cool technology that seems to be there but is not quite. All right, so let's start with our introductions. Philippe, can you kick us off?
Yeah, sure. Hi, I'm Philippe Carroll. I'm product manager with Anevia. Anevia, we are a multi-screen software company founded by the creator of the VLC media player. We are specialized in OTT software for cloud DVR, for on-demand and live services. And Anevia, we recently acquired Qwilt, which is a software encoding and compression company for OTT TV. So basically, we provide an end-to-end solution for the OTT delivery chains for broadcasters and telecom operators.
Fantastic. Thank you very much. Neal?
Hi, I'm Neal Geary. I'm a technology strategy consultant for the operator Liberty Global. We're a cable operator in many European markets. The brands we use are such as Virgin Media in the UK. I'm based in London as well, and that's where I've come from. Merged in, about 5 years ago. And we also have operations in about half a dozen other European countries. We offer cable, TV, high-speed broadband up to sort of 400 megabits and higher coming soon. And we have our TV products that are based on both traditional set-top boxes, but also growing is our TV Anywhere. Usage of our TV Anywhere services is growing as well. We have an app called Horizon Go.
Fantastic. Brian?
Hi, my name's Brian Stevenson. I head up IP video strategy and innovation for Nokia. And Nokia is very deeply involved in IP video delivery and HTTP. We provide everything from CDN services to personalization to ad insertion, and we provide those services really either as a product that the operator can take and install, or we provide it as a service. So if a SaaS offering is more appropriate for you, again, you can have a PaaS or a SaaS offering that provides a lot of the same functionality that our products have. And so really in terms of Multicast ABR, my background is that, I've worked on this at several companies in my history. I contributed quite a lot to the Cable Labs, the initial Cable Labs specification, and currently working, although a little bit at arm's length, on the DVB application.
Excellent. And lastly, Mark.
Yeah, hi everyone. It's good to be with you. I'm Mark Fisher, responsible for marketing and business development at Qwilt. Qwilt is a software and cloud services company. We sell our software to service providers. They use it to optimize delivery of streaming video, live streaming, and other content across their network. We help them enable an edge cloud inside the service provider network to optimize their own network, but also help the entire ecosystem with higher quality, more scale, and better overall delivery. We're particularly interested in this topic today, Multicast ABR, because this is one of the technologies we're helping enable in the service provider network as it's part of the overall optimization and strategy for them. Good to be here.
Awesome, thank you guys. All right, so it's a great cross section of experience and companies to talk about this technology, and something that Brian mentioned in his introduction. Obviously, Multicast ABR has been around for a while. Cable Labs has developed a specification. DVB is working on theirs. There are some others that are floating around. I think maybe to start out at sort of a really high level, and Brian, maybe you could kind of continue and kick us off on this, is to answer the question kind of, what is Multicast ABR? So how does it work? How does it differ from unicast, and what are the things that people know? And I apologize to our attendees. Maybe this is a little rudimentary information for you, but I just kind of want to get this definition out in the open so that we're all working from the same page.
Yeah, so basically, as you said, Multicast ABR is really fundamentally different from sort of standard HTTP content delivery that we're sort of used to with CDNs. Multicast ABR does leverage the same content source as HTTP. So as I'm creating those fragments, it's available, or the origin can actually make them available to the multicast delivery pipe. But it actually pushes those fragments over UDP. And so instead of sort of being a request model where a browser or a cache sitting lower in the infrastructure comes back and requests those fragments are actually packaged and pushed out over UDP using a protocol like Qwilt or Norm. And the contents are actually broadcast to every client that's listening in. So you can think of the client sitting downstream really as being a subscriber and really consuming that content as it's being pushed out. So each ABR client, in effect, doesn't request its own stream. And if you look at what DVB are doing and what Cable Labs did, there's really three core components to any MABR solution. Firstly, there's the multicast server that really ingests, ABR content at source, encapsulates it up in a Norm or a Qwilt package, and really broadcasts it as a multicast stream. The second part is really the multicast controller that manages basically the unicast to URL multicast mapping for live channels or for files. It manages carousels, if you happen to do file-based delivery, and it really distributes the mapping of where you actually need to go, which URL or which IP address you need to tune to actually receive that content on a downstream client. And then sort of finally, sitting at the network edge, you have the multicast client or multicast proxy. It can be either embedded in the CDN sort of pre-cache, so it actually provides a lot of scale to the CDN as the multicast content is being distributed. The cache can actually pick it up and cache it and use it as a normal HTTP fragments. It can be deployed on something like a residential gateway or an ONT, where it acts really as an HTTP proxy for legacy type devices, or it can actually be embedded into CE devices. And so we've seen lately a lot of set-top boxes have come with the functionality that allows them to really consume multicast ABR.
Oh, very, very cool. Anybody else have anything to add to that?
Yeah, JT, it's Mark. Let me just add briefly to Brian's perspective, which was excellent. As we talk to our service provider customers, and some of the larger ones include Telecom Italia and Verizon, there's a common theme, which is as we move to all IP networks, as we see more streaming, both from our own online video offerings and from maybe our partners who are streaming live events, they recognize that there's one problem that needs to be solved, which is how do I handle what's most often a mass live, often sports event where instead of people tuning into a traditional broadcast signal, they want to stream it to any number of devices. And so the prospect of tens of millions streaming across their network, the same stream at the same time, I think lead many to this conclusion that how can we, I'll say, kind of mimic a broadcast-like network efficiency, but use streaming, IP streaming as the means of delivery. And that, I think, fits nicely with the value proposition of Multicast ABR, which is, at least from a service provider's perspective, helping address this need for these mass events with a highly efficient architecture that really diminishes, maybe, almost eliminates the possibility of real congestion in the access network because it can create this broadcast stream that everyone can view at the same time. So this is maybe stating it as more of a service provider business opportunity, if you will, and that's where we see the real interest pick up now.
Okay. Neal or Philippe, do you have anything to add to that?
No, actually.
Neal. Yeah, Neal here. I was just reflecting on that, and something just we should be aware of perhaps is that Multicast ABR is a little bit more complicated in terms of the delivery chain. Philippe has explained it really well. But what we're comparing against is what's been very successful, which is HTTP adaptive streaming, end to end from the CDN down to the customer's device, and that's moving across the Wi-Fi of the home network as well. So maybe we'll touch on to this in some of the further questions, but it's a little bit more complicated than what we're used to, like the unicast.
Agreed.
Yeah, that's a very good point. And actually that brings up sort of the second question that I have is, what are the primary use cases for Multicast ABR, right? Where does it really work? Is it great for mobile networks, for mobile operators? Should it be something that's implemented behind, at the home gateway, either at the set-top box or the Wi-Fi router? Is this something that CDN should be involved in? So what are the use cases for this? And then where does it fail? Where is it like, Multicast ABR is just not going to work there? Anybody want to jump into that one?
Yeah.
Yeah. Go ahead, Philippe.
Okay, thanks. Yeah, basically, in terms of content itself, Multicast ABR is really strong for live content and for really popular content, because the main concern is really to avoid congestion on your access network. So the more popular content is, if you can just provide one multicast stream instead of having all your unicast stations fighting for it, it's where really it really works. And then of course it needs to work on your managed network. The network itself, being the home network, the access and transmission network, basically from the multicast server to your client, needs to be multicast ready. So any managed network will work, and this is where you can't really use it on the public. You can't use it on the public internet. Yeah.
But this is an additional tool that operators can use to distinguish ourselves against the OTT players. So as you say, Philippe, on the public internet, this isn't going to work. Our OTT friends and, sometimes frenemies, both friends and enemies, they're not going to be able to deploy this, I believe, as far as I'm aware, because they don't have that full managed route to the home. They're relying on going over operators' networks. And so if they start to move into live TV channels and popular content, really want to compete with, the major networks on TV channels and have a live schedule, then this is something that operators can deploy, but the OTT people may struggle with.
And I think too, sorry, really just sort of touching on those points, it does provide much more of a sort of classic TV type experience where, you know, the propagation delay is really minor compared to HTTP. Fast start, you know, provides more of that legacy channel change really experience. And even though it's multicast, you know, it still doesn't mean that it can't be personalized. So there are a number of ways to do things like, you know, targeted ad insertion or very targeted ad insertion within those multicast streams. So even when you're replacing the ads, that can be targeted at a house or a particular individual, and using the same sort of technologies or the same sort of methodologies that you do for delivering VOD content. So being able to sort of pre-position those ads really at the side of at the edge of the network to sort of avoid large unicast bursts during ad avails. So you can almost combine, you know, a lot of the classic TV features with some of the more HTTP-like features around personalization and customization of the service.
Yeah, it's Mark.
And,
an additional point maybe on this. I completely agree with what Philippe and Neal had mentioned, and it seems to us as we see it unfolding, the sweet spot is within the service provider network where they have, let's say, really control of the multicast client in the home. Let's say that's maybe the set-top box or the wireless gateway, and obviously the network end. As well as the content that's being streamed. So as I said, this could be their own live streaming, or maybe it's a partner live event where there's a clear relationship with the content provider, because then you're in a position to really move through the process of, you know, deploying architecture, enabling client devices in the home, integrating the whole effort. And then I think, and this is important, is the consumer, the person in the home, let's say, with holding a tablet or a mobile phone or looking at a smart TV, I think they're really not being asked to do anything other than select a live stream and watch it. And that's, I think, critical for, you know, the eventual adoption of this more broadly. So I agree that the sweet spot for where this solution works is within this managed content service provider realm where the, you know, the incentive for optimization and creating scale of delivery is clearly there.
Yeah, so what I'm kind of hearing from you guys, you know, around what are the benefits of multicast ABR on the operator network side is, you know, you decrease network congestion, right? So instead of everyone requesting the same stream and having to backhaul that over the network, you've just got one stream that everyone's watching. Are there other benefits, you know, maybe scaling, maybe, you know, architectural efficiency, you know, just what are some of these other benefits that operators can grab onto with multicast ABR?
Jason, I've got one. In the home, so this is not about scaling, but this is about the architecture of the in-home network. Before I worked in cable, I worked in incumbent operators and what we have in Europe, unbundled operators. So I've seen sort of both sides of it, before cable and also now with cable operators. But IPTV operators, certainly in Europe, spend quite a lot of money on these power line adapter units, essentially to do plumbing jobs inside the home. So it's a very typical challenge in especially European homes. Our homes are not really built with structured cabling running around them like some of your American homes are. And therefore, where the telephone line comes into the house for perhaps a Deutsche Telekom or a Orange France customer is often nowhere near where your TV is. So IPTV operators have had to really sort of kludge their way through this problem. You know, they want to get Ethernet essentially to the set-top box, which is where the TV is. And, you know, it's too far. So they've had to deploy power line Ethernet adapters, and that adds a lot of cost to their own in-home delivery. And why are they doing that? It's because their IPTV using traditional multicast can't really go over Wi-Fi. Your only choice is something wired, such as Ethernet or Mocha. Now, we don't really have Mocha deployed much in Europe, so these power line adapters are quite a major cost, as I understand it, to the incumbent operators deploying IPTV. So something like Multicast ABR may also help those kind of operators in optimizing their customer premise equipment spend. Because as I understand it, based on what Philippe described on the architecture, all the clever stuff happens in the broadband gateway. And the client device, in this case a set-top box, simply makes a request and then it comes back seamlessly over Wi-Fi because it's a unicast stream within the home. It's not multicast all the way to the set-top box. So I see that as another benefit to Multicast ABR for those particular IPTV operators.
That's very interesting. Anybody else?
Yeah, I've got another one.
No.
Jason. Yeah, I mean, if you think about our set-top boxes that we deploy in the cable world, we're very much tied to the SoCs, the system on chip, the chipset vendors who are specializing in cable, you know, the likes of Broadcom. And there isn't a huge amount of choice for us there in that market, I would say. You know, one key advantage that Multicast ABR may unlock for ourselves as operators is to sort of get onto a new track of set-top box economics. And that could be by going to an all IP set-top box, you know, so removing the DVB-C element from our set-top boxes. And I think Multicast ABR, I think it was Brian mentioned earlier, is essentially an equivalent to the broadcast route to the set-top box, but is being done all over IP. So that could be another benefit for cable operators to sort of change their economics, subject to lots of other factors, I'm sure, but to get onto maybe the more ARM-based chipsets that have really come down in cost significantly because they're being deployed in their millions and billions in all the smartphones and customer devices that surround us.
And I think that's an interesting point because really it does give the operator the ability to standardize on a single backbone. One of the interesting things that's currently happening is, you know, people are either adopting Multicast ABR or really HTTP as their backbone. And even for legacy device support, you know, there's this concept of a video core that most of the CMTS and CCAP vendors are actually offering that actually takes the multicast content and really just converts it back to a multi-program transport stream. So effectively, even though you're standardizing on the Multicast ABR backbone, it really gives you the ability to continue supporting those old SA and Moto devices, you know, for years into the foreseeable future, while kind of decreasing the investment on traditional QAM technologies.
So this actually brings up an interesting question. Because what you guys are describing, so what Brian initially described as sort of what is Multicast ABR and, you know, some of the other things you guys have been talking about, and then these, you know, these benefits that Neal kind of, you know, outlined. You know, what are the sort of technical gotchas for implementing Multicast ABR? I mean, you know, what do network operators have to keep in mind when thinking about, hey, should we deploy Multicast ABR into our network?
Yeah, I can step in. Basically, I mean, one of the main important aspects is really the integration of the client in the gateway, and really, I mean, integrating. I mean, doing all the integration work, and depending, of course, on the operator, but you will have different gateway models. Sometimes the gateway is provided, sometimes it's not. So here you got to pay attention really to all the integration on the client side. The other aspects are really for the monitoring itself and the decision to switch from unicast to multicast for a dedicated channel. So here you need really to be careful on your reporting from all the components to be able really to optimize your traffic at this level. And then I would say another aspect is also really when we say we have to realize that one specific stream cannot address all the devices in the home network when you are talking a second screen, because, for example, you will have some devices working only in HLS or in Dash or working with specific DRMs. So, of course, things like MPEG CMAF will address this point, but you also have to take decisions on which devices you want to address within the home. So which packaging technology on which DRM you will actually multicast. On the other aspects will really be the integration and the support of, because you will still have some channels in HTTPS or in HTTP, I mean, on the unicast, you will also have to address all the HTTPS support, for example. So security, you can't just act as a proxy and intercept all the traffic on the gateway level.
And I think you make a great point there about reporting, because if you look at some of the protocols that are being deployed, so Norm, say, for example, it gives the clients the ability to effectively knack back, if they receive an error or receive a bad packet. And I think it's good network design is really key to deploying this, because if all those clients, if every client in your network actually begins to knack back, that's very difficult to kind of manage in terms of the network saturation and network utilization. So I think it's very important that these systems are really designed well before they're deployed.
That's right. I think this increasing complexity, from a more complex delivery chain and having the broadband gateway as almost this essential element in the middle, we need to make sure it can be troubleshooted, such that our care agents in the call centers can identify where the problem is, in case of problems. Is it with the set-top box? Is it with the Wi-Fi? Is it with the broadband gateway has problems? It makes for a more complex delivery chain, whereas when you're comparing to IP unicast, the beauty of HTTP adaptive streaming, it's so robust, and nothing special is required on the client either. That's what our customers are used to on their devices. Unicast, we need to make sure it is at least as reliable and at least as easy for us to troubleshoot, because our customers call us when they have any problems with Wi-Fi. We used to think that our network stopped at the broadband gateway, but we've now very much moved on from that. Our network responsibility really extends into the home, across the Wi-Fi, and we've got to make sure that all the customer services they're expecting to use work all the way down to their device.
Yeah, I agree that complexity, I think that's the fundamental point, as was said several times here. Complexity is so much greater that it makes for a far more difficult deployment and integration and operation of multicast ABR. I'll add one specific additional example is, at least in our experience in Europe, we found that in some cases, the single greatest source of mass live stream traffic is coming over the top. It's not, sitting inside this service provider's managed content portfolio or anything they do with partners. So if now you're driven by a third-party over-the-top mass live streaming event and you want to use multicast ABR, it adds even more complexity, because you need to potentially manage that third-party relationship to really take full advantage of this kind of optimization. So, there's becomes discussions of exposing APIs to third parties who can then request that multicast ABR be invoked for certain live events and so on. And again, this adds to complexity, and I think all of this taken together has probably explained why the ramp up on this is still taking time.
Well, and that leads me to sort of the next question, which is, maybe this is really easily answered, but have we seen any deployments today? Has anybody put this into practice? Has anybody done any, real benchmarking tests, showing what it can do, delivered content over it? Does anybody know of anything?
So there is one large tier one in North America that's actually been using this for quite a while. We're currently doing a number of trials with both cable and IPTV operators, and really when you look at some of the feedback that we're getting through our testing, in a typical scenario where you may have sort of 100 channels being delivered over multicast ABR, once you get to about 200 viewers actually consuming that content, which may be around 20 DOCSIS channels that's required, really the requirement for DOCSIS channels really never grows. But clearly compare that to HTTP, which sort of grows like a hockey stick. So when you reach about 200 users, if they're consuming those channels, I mean, the requirement is probably around about 80 DOCSIS channels, and it does keep growing. So really, we're definitely seeing a lot of savings, particularly on shared networks like cable.
Yeah, I mean, we got some commitments from thanks. We got some commitments from some customers, and we are also doing some proof of concept with customers. For example, one major cable operators in LATAM. And what we see, I mean, yeah, there are the challenges on the network. It's also another challenge is really the integration of the client and the multiple gateway models that they have. And because in general, we got multiple generations of set-top boxes, of gateway, from different vendors. And really, I mean, their concern is really this creates so much complexity, all this heterogeneity, that basically it increases the required return on investment because it has a cost. The project itself, all this upgrade as such a cost, but you need to be careful of your return on investment there.
Yeah, so I think it's all about your need for capacity in the various layers of your network, and where are you feeling the most pain. Certainly, as a cable operator, there are parts of our network where the spectrum is pretty utilized, and we have to be very efficient with how we allocate it between broadband and TV. But where we're starting from is where all of our TV channels today are broadcast, and it's about getting to the right point where you might decide to move some of the long tail content, the unpopular channels or the less popular channels, whether you want to move those to IP delivery to free up spectrum. And you could do that unicast just because they are the long tail channels. We spoke earlier about the sweet spot for multicast ABR is really the short tail, the most popular content. Now, where we will likely move first is moving the long tail channels away from the DVB-C broadcast and to IP delivery. And there you don't see quite the bang for your buck in terms of moving to IP delivery with multicast ABR. Just like to throw some numbers out there. When we look at the streaming that's consumed by our customers today, certainly some of the OTT providers are very much dominant on the on-demand side. So, Netflix is 100% on demand. Amazon, right, there's a tiny fraction that is live, and the majority is on demand as well. YouTube is, again, the majority on demand. Even the BBC iPlayer, so that's a traditional broadcaster here in the UK with their over-the-top service. They've quoted stats from last autumn. Only 17% of their viewing requests on their OTT platform were for live content, and so the vast majority was for on-demand. So it's when we reach a tipping point, and if we reach a tipping point, that the short tail content becomes painful to deliver. And that's when technologies like multicast ABR, sort of the box gets ticked.
Yep, agreed.
That's really an interesting perspective, because that sort of puts us in the position of, wait and see, and then rush to implement when there's pain, instead of laying the groundwork early and getting it implemented, and then sort of, you know, trickling it on and increasing capacity as demand grows. So that's a very interesting perspective from an operator network. You know, obviously, something we talked about way early on in this discussion is, you know, the industry has been discussing multicast ABR for a while, and I'm actually really excited to hear that, you know, Anevia, that you guys are doing trials, and you know, Brian, that Nokia, that, you know, that you know of a cable operator that's using this, and you guys are in, you know, POCs with others. That's fantastic to hear, because I am definitely one of those people that's all about, you know, start implementing now so you can tackle the challenges, and you're not kludging something together at the last minute to sort of solve a problem that you probably could have solved, you know, 18 or 24 months before. So obviously, Cable Labs has had to spec out. DVB is working on theirs. You know, we've done at the Streaming Video Alliance, we've done a POC with a couple of our member companies around multicast ABR and the home gateway. What is the primary obstacle to seeing more deployment of this? Is it really sort of what Neal's talking about? You know, kind of like, you know, the demand's not there yet, so we're not going to do anything. Is it, you know, more what Philippe's talking about around sort of, hey, you've really got to make sure about your ROI? Is it, you know, all about the complexity? Kind of what do you guys think about that?
Yeah. So for me, I think it's a combination of Philippe's point about the sort of pain to have to go through the integration on your multiple generations of broadband gateway. You know, the agent does consume RAM and processor cycles, so probably would not be suited to some of the older devices out there. Now, that pain will reduce over time, because we're really pushing out our latest broadband gateways called the Connect Box, and there'll be future generations of that, you know, one with RDKB architecture as well. So those pain points about doing the development and the integration are decreasing over time, and the benefits, as we were saying, may well increase over time. And, you know, that tipping point is probably when those two trends reach the right balance and combination. And yes, would be great to be prepared for it in advance, yes.
We're seeing some, just back to the point of deployments and interest, we're seeing a number of very serious requests for deployment from large tier 1 operators in multiple regions, Europe, US, and in Asia. Big operators who are taking this very seriously, and I think they perhaps are arriving at the conclusion that it won't be long before this intersection that I think Neal just described between, you know, clients in the home, the set-top box, say, being ready to handle this kind of task, plus the growing pain of mass live events is intersecting. One other point is that, you know, I think in many markets, certainly true in the US, where the rights for broadcast to big live sporting events are often rotate, you know, over the years between different owners. And so you have different third parties over time who show up to, you know, broadcast the World Series or the NBA championships or the Super Bowl, and or maybe even the World Cup perhaps. And, you know, that adds to the kind of complexity, because then you have a bit of a moving target as to who needs to participate in this, in accessing this technology. And so, you know, this is another dimension that needs to be addressed.
Yeah, definitely the content angle is important too. I mean, I can remember about a year ago, we had one of our busiest days on our Horizon Go OTT TV Anywhere platform. And it was where two events coincided on the same evening in the Netherlands.
That's excellent.
On the one hand, there was, maybe not all of you are aware of it, but there's this annual singing competition that is sort of pan-European across many countries, the Eurovision Song Contest, very popular. On the same evening, on the same evening, there was a football match locally in Netherlands between two of the big teams. And you can imagine the discussions going on inside all of our subscribers' homes. You know, what are we going to watch? They're both on at the same time. So one member of the family probably got pushed upstairs to the bedroom and was watching, you know, what the opposite service, either the football match or the song contest on their device, on their smartphone or tablet. And, you know, it's when those two content forces coincided on the same night, capacity-wise, that was, you know, the most challenging day to serve.
And that sort of, that brings us to kind of another question that's related to this one. Thinking about what Cable Labs is doing and what DVB is doing, and sort of how traditional broadcast has been shaped by standardization, right? So things like SCUDI and other standards that form the basis around how technologies work and interoperate with each other. What still needs to happen with Multicast ABR to sort of make it become reality outside of the ROI justifications and things like that? Are there, do standards need to be written? Are there technologies that still need to be developed, or technologies that need to be improved? What still needs to happen?
So I think from having worked on the Cable Labs document, really I would see that more as a technical report. It's a very, very good document, but again, it's more of a recommendation or best practices document rather than a full standard. I would think, particularly if someone like SCUDI could actually pick that up, continue the work, and actually turn that into a full standard. I think it would go a long way, really, to help standardize the approach. Now, DVB are sort of in the process of doing that, but definitely I think we could be doing a lot more work really on the standards and even the underlying transport protocols. I mean, there are definitely some around norm and around flood. There are definitely some enhancements that we can make to make the deployment robustness, reliability a lot better.
Yeah, I mean, just to complement this, and this is true, but there is actually, and I'm going a bit off track here, but there is actually one group that standardized something which is not for Multicast ABR, but when we look at 3GPP that standardized LTE broadcast, and which is actually based on Qwilt. And this can be also really useful for convergence for mobile and cable operators. I mean, when you got two networks and you want to serve them with the same technology, with the same service, it can make sense to actually converge there on your technology as well.
Anything you're seeing from your neck of the woods, Neal? Anything you think is missing that needs to be improved or added, or?
I'll have to ask my architect colleagues who are sort of deeper in this than myself, but it'd be interesting to learn more about actually that LTE broadcast, and perhaps the two technologies together will essentially enable that full vision of you have your home TV package, and then you can watch that on the go, also anywhere, but where the operator also benefits from the capacity savings in the network. That could be quite compelling for operators who have fixed and mobile together.
Yep.
Right. Okay. Well, let me take a pause here, and I want to grab a question from the audience that came in, and it's a very interesting question because obviously on the horizon of video delivery, just streaming video in general is mobile, right? So I think Cisco predicts in their VNI report this year that by like 2022 or 2020 or something like that, like 80% of mobile IP traffic will be video, right? So people are watching on these small screens. And now you've got the talk of the town being 5G, right? So with a massive amount of bandwidth down to these little devices and potentially into home gateways, right? As people deploy 5G enabled routers in the home, will we need multicast ABR? Will it even be necessary in an environment where we have that much capacity available for typical unicast HTTP streaming? Brian, maybe you can kick us off because you're from Nokia.
Okay. Well, I think there's really two schools of thought, So if you look at 5G, the promise is really, hundreds of megabytes delivered to thousands of users. And really, you're looking at things like even going beyond the mobile device. So as you mentioned, home gateways, so really fixed wireless access, delivering IP services and content, et cetera, into the home. And so there will certainly be a lot more bandwidth available for services like video and VR and AR and those types of things once 5G begins rolling out. I think part of the problem, though, is even though the bandwidth is available, you still really want to use it just to consume unicast video sessions, because I've heard the argument where when 3G comes out, we're going to have tons of bandwidth. When 4G comes out, we're going to have tons of bandwidth. and I think the same thing is going to happen with 5G. I mean, we're going to find some way to really use that bandwidth. So I think ultimately, just sort of given some of the advantages that we've talked about multicast, where it is really more of a classic TV experience with latency, fast start, and that kind of stuff. I definitely think we're going to see multicast ABR really continue, or even LTE broadcast continue to be delivered over the 5G network. One of the interesting things with 5G is it's really got this concept of network slicing built into it. So, even someone that wants to deliver content and they actually want to use LTE broadcast to do that, they can actually go and lease a piece of that spectrum from their local or their national carrier, and actually have that dedicated really to the services that they're providing. So if they want to do, sort of a very lightweight sling type TV service, they can actually do that stuff through network slicing, and they're guaranteed full QE. They're guaranteed a certain amount of bandwidth to actually deliver that. So I think these sort of new features within 5G really open the doors, in conjunction with multicast ABR, to a lot of different services that I don't think people have contemplated yet.
Yeah, agreed. And I think Brian points out correctly, we're really trying to shoot a moving target here, because in as much as we're talking about a certain state today of streaming, the march of increased resolution 4K live streaming, combined with increasing audience, it's relentless, and it's not going to stop. So I think it just demands that things like LTE broadcast, multicast ABR all be considered and deployed where it makes sense, and the operators have to make the decision about the investment and ROI and timing, of course. But I think these are, in our view, kind of inevitable efforts of optimization to continue to scale. And just to put it into some perspective, I mean, we have many broadcast television events worldwide, all of which have eclipsed, we think, 1 billion simultaneous viewers in traditional broadcast. I think, even being generous, if you look at what Akamai has published and others, it's not clear if we've ever exceeded 5 million simultaneous users or viewers for a streaming live event, something in that range. So the problem domain is a couple orders of magnitude, and I don't think it'll change. So as Brian said, 5G will be consumed quickly, and we'll still have to address things like this to do optimization.
Anybody with some other perspectives on it? No? All right.
No.
I mean, obviously, yeah, obviously 5G, there are still the inside of the operator networks to consider, right, where multicast ABR can really help, over that managed network, fixing that congestion problem. So obviously, I think everyone probably agrees that there is no one silver bullet. Obviously, we're, trying out new technologies in HTTP streaming like WebRTC. That works maybe in conjunction with better congestion management technologies within the network, which works great with increased capacity, for the mobile network. So I think there's probably, from what I'm getting from you guys, there's a lot of different components that are in the mix, which will eventually lead viewers to a broadcast-like or better than broadcast-like experience with streaming. All right, let me ask this question. It's sort of my wrap-up question here. we've got about 10 minutes left. I want to leave a little bit more time for another question from the audience as well. But if you were to give a piece of advice to a network operator considering deployment of multicast ABR, what would it be? Right, and this could be business advice, it could be technical advice. Just let's kind of start with Philippe, and then we'll go through the line, and then we'll see if we've got any more audience questions.
I would really say to be careful of the cost of integration on the devices, on their complexity, to check the ROI, of course, and to check the overall complexity on the usage of live, on the consumption of live contents, really, because multicast ABR is mostly for live. So the consumption of live content compared to on-demand and delinearized contents.
All right, Neal?
Yeah, building on that, I would give the advice to really understand where in your network you're going to see the benefit. Are you going to see benefits in reducing CDN costs? Or is it in the IP core and the backbone? Or is it perhaps in the access network if you're a cable operator or a mobile operator? And even, as I mentioned earlier, could it be in the home where you're populating out all these power line adapters just to get around a particular technological problem? So which of those scaling challenges do you have most urgently? And if multicast ABR fits, go off and do your business case.
All right, Brian.
Sorry, the only word of advice I could give would really be consider standardizing on a single format. And so clearly with things like CMAF coming out and really single encryption schemas around the CMAF fragments, it really gives the operator the ability to make multicast ABR a reality, because clearly you want to multicast those fragments once. You don't want to multicast several different versions of them, because that really does diminish any kind of gains that you're getting on the network. And so I think as we move forward, and I think as we see CMAP being rolled out and adopted, it really makes it a little bit easier to kind of deploy multicast ABR and sort of similar technologies.
Mark?
Yeah, I think the advice we're giving pretty consistently is to suggest to the service provider they maybe reframe this. Instead of, I have a problem, I need a solution, think about this as we have an opportunity to invest, to create new capability. Does that open the door to new partnerships, business models, or possibilities? So in some cases, we think that because the dominant live streaming traffic is coming from a third party, there are service providers who realize that with this investment, when they think about the increase in that third party's traffic over time, there's a chance to bring them in as a real partner, so that the what is now OTT kind of happening to the service provider becomes an integrated content delivery strategy using multicast ABR as a means of both optimization and ensuring quality for users. And now you've created a whole new ecosystem partnership that perhaps wasn't there before. This is, I think, where a different framing really helps people see a chance here to invest in a wise way.
All right, so back to our audience questions. So we had a question come in just a couple of minutes ago, and basically they're asking, would collapsed CDN, so at a single tier level, would that look more attractive to an operator for delivery versus the complexity introduced by multicast ABR? And then they went on to clarify a little bit and said, even peer-to-peer is starting to be used by some players to help. Does anybody want to address that?
Do we mean collapse CDN as perhaps a CDN deployed at the edge or even in the customer's home? Is that what we mean?
I think so. I think that would probably make sense for that question. Yes.
Yeah, I mean, I'll give it a go. So, as operators, our networks were full of peer-to-peer traffic 5, 10, 15 years ago, and it was basically filling up the pipes. particularly in the upstream direction for cable. So there may well be a role for peer-to-peer type delivery solutions. There's a few startups out there doing clever stuff, leveraging standards like WebRTC for pushing traffic from user A to user B seamlessly for live streaming. And that may be another approach for essentially reducing your cost of delivery of the first-party video traffic, because you're sort of bypassing a lot of the network. It's going from peer A to peer B.
I mean, and that makes sense. I mean, so obviously, I think what you're saying is there's no one way to skin this cat right now, right? It's obviously the network operator has needs, reduced congestion, better traffic management, ROI, all of that stuff. And, maybe multicast ABR is the way to go, but there's a lot of complexity to implementation. So maybe there's another solution that could do something similarly, but, maybe not as effectively, maybe better, I don't know. But that seems to be what I'm hearing, not just from you guys, but from the market in general, is that there's not just one way to solve this problem of scale and broadcast quality online streaming. There's everybody seems to be trying different things. Would you say that's the case?
I mean, I think so. I know people are at least many of our customers are really out there experimenting with sort of different protocols and different methodologies. I think the key is, though, to be able to deploy these things in a way that makes sense. So, clearly for multicast ABR, I mean, live streaming of large events to many subscribers, or actually using multicast ABR to deliver content or scale content delivery across the backbone really makes a lot of sense. I don't think it makes sense where you actually go and are sort of trying to replace, caching or really try to serve up long tail content over it. So I think what's key is really to sort of distinguish where multicast ABR can make a difference and really use it in those tiers within the network where it's most efficient.
Yeah, I agree. And as a principled view of this, our perspective is we think that service providers have a chance here now to build an edge cloud, just like the centralized clouds from Amazon and Microsoft and the rest have their place. There's an edge cloud opportunity in the service provider last mile network where a whole set of applications can be enabled. Right now, we're really focused on content delivery. But if you do that, you follow the principled architecture that says, look, let's create a real, proper, fully functioned content delivery architecture within the last mile network. Let's push popular content delivery, whatever it may be, live streams, VOD, Apple software updates to the edge. And then let's use as a tool multicast ABR, as was just said, where it makes sense, where there's a need, an opportunity, and where the investment clearly will pay out. So I think this is, this works when you're following a principled architectural path over the long run that creates the right long-term network architecture for all these new applications that are coming our way. And we haven't talked about many of them, right? VR and AR and IoT and self-driving cars and the 360-degree video. The list goes on, which will all drive kind of traffic in new ways with new profiles that have to be considered.
Absolutely. All right, guys. Well, listen, we are out of time. So I want to say thank you to our panelists. This is a fantastic discussion. Obviously, this will be, as I said before, recorded. We'll probably get up onto the website a little bit later this afternoon, and then there'll be an email that goes out from GoToWebinar for all those people that missed it, that provides a link to that on-demand asset. But again, and thank you for all of those who stayed with us through the end. I hope we provided you a lot of great information, and you can take this back and really discuss sort of the place of multicast ABR in your own organizations and figure out how you guys can contribute and deploy and all sorts of things. So again, thanks everybody, and have a wonderful rest of your afternoon, and take care.
Thank you.
Thanks.